Hi, race fans. I am here with the amazing and talented Cara Adams, who you recently were just promoted, right? In November?
November of the year before last,
Oh, yeah,
actually.
that's
Yes.
last year. That's right. You were
Yeah.
promoted, but so you're,
2020 just flew by so fast.
it's crazy. 2020 was, and I was only able to go to CODA testing. And then after that, it was done. It was done for me. Okay, it's a long title though that you have. You are Director of Race Tire Engineering and Production for Bridgestone America's Tire Operations and Firestone Racing. Is that correct?
Yeah, a little
Okay.
bit of everything.
A little bit
So
of,
I have chief engineer duties where I'm in charge of all the specifications that are released for the IndyCar series and all the other forms of racing that we're in. I also am in charge of both the engineering side and the production side. So manufacturing, making sure the tires get made correctly and get to the track. So it's a lot of responsibilities, a few gray hairs as well.
I'm sure. It sounds like a lot. It's totally a lot there. Well, let's start off with just getting to know. I won't, a lot of people we hear chief engineer, we hear things like that, but what exactly does your day-to-day look like when whether you're on the track or at the factory, right? Do you
Mhm.
often you're okay. So what does that look like for you?
So I am responsible for the team that makes Firestone Racing happen. So those safe Firestone Racing tires you see out on the IndyCar racetrack, that's all my team that's putting it together. So I actually started in our tire engineering group, and I started on our NVH diagnostics, which is looking at vibrations in tires. I moved over to race, started engineering our street course tires, then road course, oval tires, and then I took over engineering and now engineering in manufacturing. So just keep biting off more. But what a typical week looks like for me, and now this is the beginning of 2021, so this is COVID times. I do probably 2 days a week, or some more if needed, at the plant. So I'm at the plant around 5:45 a.m. and working with everybody to get up to speed. Then I may be in the office a little bit. And right now, most of our team is working from home. If they're not in the plant, the engineers are mostly working from home. So I work with my engineers when they have questions about designs, or chemists when they have questions about compounds. The chemists know much more about chemical engineering than I do, so I might offer some guidance, but they're the smart ones. And then my mechanical engineers are asking questions about structure and orders, and we have project management that goes through. So really what we're doing is we're looking at the whole design cycle for the IndyCar tires, from an idea of, hey, we're going to put a new aero screen on the car. What effects is that going to have on the tires? All the way through, how do we make them? If we have any issues in manufacturing and making them, we'd solve those. So it's the entire process, from an idea of a tire going to the racetrack during the race season, where myself and my team are actually out there at the race every weekend that we have a race, and we're monitoring the performance of the tires. So there's so much goes into it. It's the entire engineering life cycle of a tire.
Wow, that's a lot. And there's no doubt, there's no doubt that tires are so important to racing. And what with all of that on your plate, what's the most challenging part of your job?
The most challenging part, I would say, one of my biggest focuses is people development. As crazy as that sounds, and as many
Oh,
technical challenges that we have, making sure that the Firestone Racing team is going to be good for years to come. So it's taking somebody who may have a little bit of an interest in racing, making sure we have the right people in the right seats, and being able to set that technical vision. So what race series should we be involved in? What should our future plans for racing be? How do we make our race tire plans fit the vision of our company? So there's a lot of people development, there's a lot of vision and strategy, and there's a lot of technical challenges too. If you look at something like Indianapolis Motor Speedway, you need to design a tire that can go above 240 miles per hour safely and grip well and be consistent, and not have a lot of wear. And there's all these things that need to go into the technical challenge of a race tire. But probably my number one biggest focus is people development.
people to them. And you just brought up a really good point that I wanted to ask you about as well. You know, when it comes to IndyCar racing, it's so versatile, so diverse. You have the road tracks, you have the street courses, you have the ovals. How do you design tires that do everything? How do you even do that?
So it's a great question. So first of all, we've been in racing since 1911. And the very first Indianapolis 500 was won on Firestone tires. Ray Haroon and his Marmon Wasp pulled into victory lane on his Firestones. So we have a great, rich tradition of innovation, of success in IndyCar racing. So we've actually learned a lot from our predecessors, and we try to make sure we're going to have a lot to give to the people beyond us. So that being said, IndyCar tires have to do a lot, from 35 miles per hour at Long Beach at the keyhole there, to 240 miles per hour at Indianapolis. The tires have to get a lot of different versatile conditions. Something like a manhole cover in a street course, and then something like a really long sustained turn at Texas Motor Speedway. So all of these different design philosophies go into the tires. We have different specifications actually for street courses, for road courses, and for ovals. So anytime you see the car on the racetrack, even though it has 4 tires and the front tires look about the same size and the rear tires look about the same size, there are 4 different specifications every time the car is on the track. So the right front is not the same as the left front. Same thing with the rear tires. So there you've got 4 different specifications that, the front tires have to be able to handle a lot of braking capacity and demand. And the drive, the traction, when the engine revs up and puts all of that torque down onto the ground, that all has to be transferred to the rear tires. So all that stop, go, and turn of the car has to come from the tires, and each position can be balanced specifically for the racetrack that we're at.
And that's, I never realized that. And I mean, I'm in the paddock, in the IndyCar paddock, and I don't really notice either how different it is, the tires, but that's especially true for ovals as well, right?
Yes.
Because and that's so important. And a lot of people, I'm asking these questions because a lot of people don't realize how different, a series like IndyCar is. When you look at a series like Formula One, they all have pretty much, they have some street courses mixed in, but pretty much those tires are going to be very different, and they need to be very different. So I'm glad thank you for explaining that, because that's something that I've always wondered about. So let's get on to the main goal probably, right, for tires. How do you get the most performance out of the tires, right? That's probably, if not the most important thing. But what does that look like when you're testing? What is
Sure. Yeah, so our testing extends beyond what we get to the racetrack. So when we are looking at our first designs of tires or looking at changing a tire, there's a lot of initial testing that goes into the tire even before we make the tire. So we would model the tire virtually, would create a computer model of the tire, and say we wanted to change an angle of something in the tire. We might take that component, we might make a change of that component, and then we would model what the results are. How does the stiffness change? What does the footprint look like? How does the tire take camber? How are the different what is the durability of the tire difference? So we're able to model all of that before we actually make a tire. So now we've taken a tire, we've made a 2-degree change on a component, and now we're actually going to build the tire. So we've gone through the design. We figured, we tested 1, we tested 4, 2 is the right number. We build that tire, and now we take it to the racetrack. But even before it goes to the racetrack, we're going to do some indoor testing on it. Every tire that goes through has a quality check, and then every new design that goes through has a lot of extensive testing. So we're going to look at things like what the spring rate is. So what spring rate? Spring rate is how much the tire deflects under a certain amount of load. So we put a load on the tire, we measure that deflection, and we're able to do that in a radial manner. So just loading the tire like you would at the track, and we're able to do like a side force and like a fore aft or a front to back force. So we're able to measure all of that. We also measure the tires on a high-speed durability drum, just like we do with our regular production tires. We're able to do lots of different tests to understand and characterize that tire, because we don't want to go to the racetrack, just build a tire and say, here's this tire, team, go test it.
Yeah.
What we would do is we would get a good idea of what the spring rate is, what the diameter change is, anything that the team needed to know about the difference on how the tire would perform. And then we give the team this is the data that we know of the tire. Here's the tire. Let's put it on the car. We don't recommend any setup changes, or we do recommend setup changes. Now let's take it for a few laps around the Indianapolis Motor Speedway and see what the driver thinks. So we'll go through that. We'll look at data, and then we may do a long run on it. So we would do all of those before we actually got to the point where we put a new specification into production if it was a construction change.
Wow, that's a lot. That's actually that's, you don't realize just how much goes into that, but that makes sense because yeah, you have to do a lot before you put the drivers, before the drivers go through this for safety issues and things like that. So when you are designing and you have all this data you're looking at and everything, at what point, when do you just feel like, wow, this is so rewarding? Like what part of your job do you just because you are working so hard from, it's almost like you have a plant and you're giving, you're putting this seed and it's growing, and those are your tires, you're developing them.
Mm-hmm.
So what's the most rewarding part for you?
So I'd say, as an engineer with my engineer hat on, the most rewarding the job is when somebody like Ryan Hunter-Reay wins a race, wins the Indy 500, and says, you know what, I had to worry about a lot of things today. I had to worry about engine issues. I had to worry about fuel strategy, but never once did I have to worry about the safety of my Firestone tires. That, as an engineer, knowing that you're able to give drivers peace of mind when they're out there doing these tremendous speeds and risking a lot, that they're not worried about their tires. Hearing that, and now as a leader of others, seeing my team hear that and really feel good about themselves, that is the most rewarding, when you get a driver that says, hey, you know what, I completely trust these tires.
That is absolutely amazing. I mean, that has to make you feel so proud.
Yeah, it really does.
Good. And it is no secret, by the way, that that the IndyCar drivers and everyone in the paddock has so much respect for you. And they do, and they you see it, and you are such an important part of IndyCar. And so how did you, and they trust you. The IndyCar drivers really trust you. How did you earn that trust? Did you have to earn it? Was it easy? Was it not easy?
So it's a great question, and depending on how in depth that you want to get,
Go for it.
the one thing that is true about racing, that you don't find in a lot of other areas, is racing is all about results. If you are able to have excellent results, then it doesn't matter whether you're brown, black, white, purple, male, female. It doesn't matter. If you're able to produce something that people can trust in, then you automatically earn that trust. So going in as a new engineer, my first year working with racing was 2007. And my first year as an engineer was 2002. And which is not 2002. Yeah, 2002. Sorry. And I always thought that, all right, I'm going to need to work really hard to show people that they can trust me. And I would work twice as hard as anybody else just to show that I belonged and I deserved to be there. And the one thing that I've realized about the IndyCar community, about many others, is that people aren't going to judge you differently because you're male or you're female. There are definitely difficulties I've had because of the female factor, and I know that's one of the things that we wanted to talk about today, but that people really just respect results. So if we had something at the track that really wasn't going all that well, we would go to the Ganassi engineers and say, hey, there's this thing, it's not perfect, and it's something that we're seeing. And they would say, oh, wow, you guys tell us when there's something that's not perfect, where we have a lot of other suppliers that they have issues and they deny that there are any issues. So we're always the first one to say that, these tires are perfectly good, perfectly safe, but here's something that you're going to notice. And the engineers respect that. So whenever you can, you give other people the respect they deserve, and then they give you the respect that you deserve.
I love that. That is something, and I want to talk later too a little bit about IndyCar and the equality and things like that, because I do feel that IndyCar has always been forefront with that.
Mhm.
They have the history of that, and we'll get to that in a second. But I love that it all comes down to results, and with results, you can't lie. You can't fake the
Yes.
result. They are there. It's there. So that makes sense, and it means that you are really good at what you do. So that's great. And one thing, we're always kind of talking about with, it's always a game, right? In IndyCar, or racing in general, you want to develop tires that are super fast, but they have to be safe. And how do you balance that? You know?
Well, to be honest, Mandy, there is no balance.
Yeah.
Safety is always, always number one. If I'm going to have a driver that says they didn't like how the tires performed, but I know that they were safe, at the end of the day, that's a win. We always want to work with our drivers, and we always ask input after every single race. We're asking them probably 20 different questions about different areas of the car and the performance of the tires, and we want all that input. But at the end of the day, safety comes first. There is no balance. But then within that safety, we have that safety first, and then we have performance, and we have speed. So yes, we are in a race series where everybody is running the same tire. We want to make something that is great for the drivers, that's fast, that's exciting for the race fans. So there's a lot of different aspects of the tire design that we do balance. We could have 13 drivers say that they want to have this performance of the tire, and 13 drivers say that they want this performance of the tire. Then you have to decide with IndyCar, what are your goals for performance? Is it ultimate speed? Is it consistency? Is it making sure at an oval you do have some type of lap time drop off so you can make some difference in racing? So there are a lot of different things that we do juggle and balance in terms of how we design our tires, but safety is always number one.
Safety. So well, good. That's good. And also, speaking of safety, the aero screen, first time was 2020 with the aero screen. That had to be a challenge. Was that challenge?
Yes.
I know that because the drivers kept, not about the tires, but
Mhm.
the aero screen. They had no complaints about the tires. It was always the aero screen. So how did you handle that? How did you handle those challenges? And there are going to be more challenges this year as well.
So Mandy, it's a great question, and it's a great team and great partnerships that put us in the position that we were. First of all, just to say something about the aero screen, we saw at Iowa the first time with two cars getting together how it was really effective. Right. So whether it's the safety of our tires or safety of IndyCar, we're always about what can we do. At one point, those crazy people were running around Indianapolis Motor Speedway without seatbelts. So I mean, we've come a really, really long ways in safety, and it's exciting to see IndyCar invest in the safety of its drivers and of the fans, and with COVID, of even the people and the fans. So safety is always great with them too. But how did we design a tire for a aero screen? It's been a very interesting process, and I'm going to tell you lots of zeros and ones, lots of data.
Wow.
So I have a great team that can analyze data like the best of them. So when we heard about the new aero screen I think it was about 6 months before we had any prototypes, we heard it was going to happen. We didn't know how heavy it was going to be. We didn't know what it would do to the center of gravity of the vehicle. There were a lot of unknowns that we had. So what we did is we reached out to our partners at Pratt & Miller, or Chevrolet and Honda, and our partners at Dallara, and said, all right, here's what we have. What do you know? Here's what we know. We want to try to get some accurate modeling of it. And some of our partners had better vehicle simulators than we do. We're tire experts, not necessarily vehicle experts. So we went to the vehicle experts and we asked for some modeling and simulation of what that was going to look like. So we take that modeling and simulation and we compare it to our current results. And then we come up with a plan to build tires. And we'll take Texas as an example, because Texas is the most extreme performance on any tire that we have, because of the nature of the track. There's so much turning. They're always turning at such high speed. So we took that data and that modeling and we put it into our models. And we said, oh boy, this is a big change. It's not a little change. It's a big change. It's going to put a lot of load under the right side tires. So for you to understand the right side and the left side differences on the IndyCar tires, you understand that there's load transfer that happens to the outside tires. So load transfer can change. If you have a higher center of gravity, that means the mass of your car is at a higher point. When you go into a turn, there's more of that mass that's going to transfer into load on the outside tires. So not only is the aeroscreen going to be heavier, but you're going to have more load transfer as you go through the turn. And it's when you're turning that you have those right side tires really highly loaded. So our initial simulation showed that there was going to be a lot of load there. So we went into the test expecting a lot of load. We knew that there was going to be some drag from the aeroscreen. We didn't know how much it was going to be. So we simulated, we added weight. We tried to work with Penske and Rahal were our test cars. Penske was able to affix some titanium up towards the roll hoop to try to mimic some of that load transfer. And we saw that there was a lot of work that went into the tires, even higher than the highest point of loads that we've ever seen. Wow. So we went through that test going, oh boy, this is a big change. We analyzed a lot of data and we said, all right, we're going to actually need a construction change because of all this extra work that's going into the tires. So we had a couple of designs that we had been working on for a couple of years. So we had actually taken those to the test with us. And so those were the tires that we tested. So the direction that we wanted to go into. And then COVID happened. So the next time we got to go onto the track wasn't until a rookie test. And at the rookie test, we start, looking at what our options are. And we see that we have the ability to run some of the new sets of the tires, some of the existing sets of the tires, but it was really, really cold. So in really cold temperatures, you're not going to really replicate what the tire does. And then COVID hit really hard and we had to shut our plant down. So we had 10 weeks of not running any tires at all. And it was going through a plant that doesn't like to be shut down. We usually have very small shutdowns over Christmas and New Year's, and we do some preventative maintenance. But we came back and we said, all right, well, in order to be able to meet this new time frame and run Texas when we need to run it, we're going to have to do something a little bit different. So again, there's a lot of data analysis that went in. We had teams giving us data after the practice sessions.
Oh, are you there?
Sorry, my phone connection cut out for a minute. We had teams giving us data after the practice sessions, and we had a remote resource in Akron that was going through data for us and looking at it and making sure that we were okay with the loads that we would see. So this whole time we've been looking at data. We have metrics from all of that vehicle data to tell us how much work is actually going into the tires. And because of our engineer back in Akron who was doing all this analysis for us, she looked at it and she said, all right, based on all of this, we know that we're going to be within this range, so we're going to be fine for the race. So there's a lot of work that goes into it. I think with the actual aeroscreen parts on the car, there was so much drag that it really slowed the car down from what it could be. So you have that added weight plus the drag, which ended up being a lot slower car, which was good in the end. So full circle, we did a lot of data analysis after the race, and that prepared us to go into this year with our new tire design.
Perfect. You just took the words right out of my mouth. I was going to just say, after such a chaotic, COVID just really affecting everything with like you said, for 10 weeks. Do you feel like you made some strides this year?
Yeah, absolutely. So there were some things that we had put in place before the 2020 season happened that really put us in a good position to be able to handle COVID. One of the things that we did is we condensed the number of specifications that we had, so that when COVID happened and the Barber race was canceled, we looked at areas where we could use those tires where they were appropriate. So instead of having a different tire specification for every race, we had some flexibility of where we could use those tires. So that helped us out a bit. And we've really relied on virtual modeling because if you can't run on the racetrack, you have to learn things virtually. So I told my team as we had our initial shutdown for COVID, let's use this year to come out stronger than we went into it. There's going to be a lot of things that we can't do, let's figure out what we can do to make us put us in a stronger position for 2021. And I absolutely do think that we are. We always have year-end team meetings with all of our teams, and we were able to take a lot of the ideas from those race teams, implement them for what we do in 2021.
Great, that's awesome. Well, and that's always good to hear, because we want racing to be back so bad, and we, more than anything, we want everyone to be safe. We want the drivers to be safe, and the aero screen is by far one of the best things that could happen. So, and the tires, it's good to know that you've been able to play a part in that, and I'm sure you're proud of that. So
Yes.
absolutely. Okay, enough tech talk.